Today we're going to talk about the reason why we have earthquakes and volcanoes, and the reason why mountains are formed. These things all happen because the surface of the Earth is not one solid piece of rock. In fact, it's broken up into a number of smaller parts, called plates. The technical name for this idea is plate tectonics. Tectonic just means something to do with the Earth or geology. These plates are actually parts of the Earth's crust, which is broken up into a number of different pieces. There are 7 to 8 very large plates, and lots of other smaller plates. The plates don't stay in the same place. In fact, they move around. Because they're so large and made of rock, they move very slowly, from about 2 to 10 centimeters a year. It's where the plates meet that things like earthquakes and volcanoes happen. The plates are all moving around on the surface of the Earth, independent of one another. Because of this, they can meet in 3 different ways. They can be moving away from one another, moving towards one another, or sliding past one another. Let's look at what happens in these different situations. First, let's examine what happens when 2 plates are moving away from one another. This happens most often in the middle of the ocean. When 2 plates move apart, they leave a space in the middle. This space is filled by magma, liquid rock, rising up from inside the Earth, and this is how new land is formed. The rocks closest to the boundary between 2 plates are therefore the youngest rocks on Earth. When the magma or lava rises up to fill this space, it can create volcanic islands. One example of this is in the Atlantic Ocean. The Atlantic is growing larger by 2 centimeters every year, and Iceland is a volcanic island right above the plate boundary. However, this kind of plate boundary doesn't only happen at sea. It can also happen on land. An example of this is in East Africa, where a large valley has been created. The next type of plate boundary is where 2 plates are moving towards one another. Plates only move a few centimeters each year, so the collisions between them are very slow and last many millions of years. When 2 plates meet like this, one plate gets pushed over the other, and one gets pushed under the other. When this happens with an oceanic plate and a continental plate, the oceanic plate gets pushed under the continental one. The plate below, the oceanic plate, sinks down deep into the Earth. This sinking causes a trench underwater where the plates meet. The deepest trench in the world is the Marianas Trench, 36,000 feet below the surface of the Pacific Ocean. What's more, as the oceanic plate sinks down, it heats up and melts. This magma or liquid rock rises up again and reaches the surface, causing volcanoes. The plate on top, the continental plate, can get pushed up into a huge mountain range. An example of mountains being formed in this way is the Andes in South America. When 2 continental plates move towards each other, they can also push up mountains, like the Himalayas. The last type of plate boundary is where 2 plates slide past each other sideways. This causes a lot of friction, which is suddenly released as earthquakes. An example of this can be seen in California. The theory of plate tectonics was first thought of in the 1960s and 1970s, but exactly what causes the plates to move around is not known. The most accepted theory is that heat inside the Earth causes rock to rise and fall in a process called convection. The hot rock in the center of the Earth rises, and the cold rock near the surface sinks. As it sinks down, it gets heated up again as it gets closer to the center of the Earth. It then starts to rise again, and the circle continues. This convection in the rock pulls the plates on the surface around. One other cause could be gravity, pulling older, heavier rock down, faster than the newer, lighter rock. Whatever the exact cause is, our knowledge of plates has meant we can understand why earthquakes happen, why volcanoes are formed, and how mountains are created. In the same way that Darwin's discovery of evolution helped us understand life on Earth, the discovery of plate tectonics has helped us understand the Earth itself.